Assalamu alaikum everyone. So this is the part 2 of the tutorial on Logisim, and today I'm going to explain more operations like arithmetic operations. This means addition, subtraction, also multiplication and division, and logical operations or circuits, which are operations where we use the and or gates for basically logic gates. I'll also show you some example of using the multiplexer and the decoder. I think many students don't grasp well the use of such components. So in the slides, you already have a nice explanation how the multiplexer works. So we do have data inputs, we have the select pins, and we have always just one output in a multiplexer. Here you have a 4-to-1 multiplexer, and you have an exercise to try to design the circuits of this multiplexer. So you can try that on Logisim, see if the operation is as you expect. I'll also show you the full adder, how it works, how we can make it 2-bit, 3-bit, 4-bit, whatever you want in your design. You're going to also see the comparator. I think the comparator is simple and straightforward. You have two numbers and you compare which one is bigger and whether they're equal or one of them is smaller. So here, the less than is 1. And it means that A is less than B. So usually the comparison happens between, so A, when we say here greater than, means A greater than B, or A equal B, or A less than B. So that's how the comparator works. You can also choose whether you want to consider it to be unsigned or signed. And of course, if it's signed, this would be different. So here A is 6 as the first example, but B, since it has a 1 here, this should be times minus 8 and not 8. So in total, this will be minus 4. So this is minus 8, and this is 4, so minus 4. And this is why you have the greater than 1. So to do this with the comparator, you just click on the comparator and change in the properties. And this is for any components. So let's go on Logisim. Okay. So here I'm going to make a circuit with some arithmetic and logical operations. So I'll choose the adder. So you have to go to arithmetic folder and adder and put your adder components. And you can choose, by default it's 8 bits, but you can choose as much as you want. I'm going to use 4 bits. And so here it's expecting the two numbers that I'm adding. So if it's two 4-bit numbers, I should put 4 bits here and put my numbers inside. In this case, I'm using inputs. For the input as well, let me call it A. I have to make the input 4 bits. And another input, B. Let me just move this away. So this is A and this is B. Now I want to add them together, so let me connect them here. Or let me use tunnels. So, because in your circuit design, you don't necessarily have inputs, but maybe you are reading from another circuit in your design. So in that case, you would be using tunnels. Make it 4 bits. So I'm adding A and B. I'm not expecting any carry in, so this will be just empty. I can also record the carry out if I want. So I can put a tunnel for the carry out. It's 1 bit. Call it C out or CO. And we have the sum. Also make it as a tunnel. Should be 4 bits. And anyways, Logisim, when you see orange wires, it means incompatible with. And this is in terms of the number of bits. So it's expecting that you have 4 bits coming from here. So this one should also be 4 bits. And just go to the properties and change that. I'll call this sum. We can also see this output by inserting the output here. Sum should be 4 bits. Good. Let's try now adding some numbers. So 0 and 0, it should be 0. Let's make B 1. So we have 1. Let's make A 2. So we have 3. We can also put an output for the carry out to see it. We can put 3 and 1, should be 4. You can put example 4 and 4, find 8. So this is the idea of a simple full adder. Let's say I want in the same circuit to have also the option to do a logical operation like the AND. So I want to AND the same 4-bit inputs, so the A and B. We have to make our AND to be 4 bits. So it's still 2 inputs, but it's expecting 4 bits going inside. And we have an output. It's better to copy paste rather than changing the bits every time. You can say this is A and B, for example, just so I know what is the data it was carrying. You can check also the outputs for this one. Call it F, and it should be 4 bits. So I'm adding A and B. It will be all 0 except for when it's 1, for the bit where it's 1 and 1. We can try to make, for example, this is 1. So that will still be 0. But if bit 1 is also 1 in B, this also will be 1. So this is an example of having multiple operations for the same 2 inputs. Now let's say I want to display one output, or I want to carry the outputs, either it's the sum or the output of the AND, depending on a user's choice. So depending on what the user, he will choose to add or to AND. And this could be an instruction, considered to be an instruction coming from a memory, from the ROM. And based on that, I will send the output to somewhere. So in this case, you should know that you could use a multiplexer, and we can go to plexers here, this folder. You can have a multiplexer. Multiplexer always has one output, and depending on how many inputs you have, or how many choices, for instance, here we have 2. We either have the summation or we have the A and B outputs. So we can put here the sum I'm ignoring the carry out for now. So either I want the sum or this output to be sent by the multiplexer. So this multiplexer, the data bits should be 4. So it's expecting 4 bits in each data input. And it has 2 inputs, so input 0 and input 1, because I only have 2 inputs. So in this case, the number of select bits will be 1. So 1 bit, either it's 0 or 1 is enough. So here I have to have an input. You can call it select or control. And here we could have an output, or you could have a tunnel that sends this output to another circuit. So it should be 4, all this out. Okay, it's out is reserved, so let's say F out. So if I select 0, it will show me the summation result, which is this. If I select 1, it will show me the output of the logic gate. So this was just an example to show you how you can, in what ways you can, or where is a multiplexer useful for. So you have many circuits, and depending on the user selection, you should choose which operation to display in the outputs. And this output, so I said you could send your output somewhere else. So for example, you could send it to a register, not necessarily you're displaying the output. So you can always display to check yourself of the values, but usually, especially if you're designing a CPU, you would have the data going to registers or coming from a register. Same as the inputs here. I put my own inputs, but if you're designing a CPU, you don't actually have inputs like this, right? You are reading from the registers in your CPU and bringing them to your ALU and then sending them back to the register that is the destination register, which is usually another register. So this was about all the arithmetic and logical, like just briefly, and how to use the multiplexer. I'll also show you the decoder. You can find it in the plexers folder. So I can pick a decoder here. Now the decoder, so this one is also considered to have select bits. And depending on how many outputs you want, you will select how many select bits. So here it's 1. If you make 2, you will have 2 to the power 2 squared. So you have 4 outputs. If you have 3, you will have 8 outputs. So what does the decoder do? As you remember, depending on the number that's entered here, so for example, I enter 000, since I have here 8 bits. So I have 3 bits here. This is what I selected. So if the number is 000, we know that this is 0. So 0 should be 1. Let's try this. Remember that the decoder is only one output is 1 at a time. So let's make this 3 bits first, this input. So you see that, I think I explained this in the first tutorial, that when it's light green in Logisim, it means 0, and it's dark green, it means 1. So here, sorry, if it's light green, it means 1. So this is, for example, light green, it's 1. And if it's dark green, it's like it's dead and off. So that's 0. So this is because it's 0, the number is 0, only 0 will be on or 1. Change it. For example, I'll put 3. 3 will be 1, and the rest are 0. So this is how the decoder works, right? You enter the number here as 3 bits. You will get as if like it's the min term or the index, the decimal number indexing for that output will be the one that's 1, and the rest will be 0. And this is useful, I think. It will be very useful in the project. For example, we have a code here that you want to go for a certain instruction. So you can put all instructions here, for example, and this is one idea, to put the instructions here, and then depending on that code, it will pick which instruction will be 1. And based on that, the circuit will operate for that instruction.